In this lesson, we'll look at enlarging or reducing shapes by multiplying it by something called a scale factor. Basically what a scale factor is a number which we're going to multiply by, which will change the lengths of all of the sides of that shape. So say for instance I was to use the scale factor times 2, that basically means all of the sides would get 2 times as long. Okay, so the shape would increase in size, all the lengths would become twice as long. If I was to multiply by 3, all the lengths on the side would basically become 3 times as long. If I want to reduce it, I would need to then multiply by something like a half, in which case that would half the length of all of the sides. So we'll go and show you some practical examples of this and see how we get on from there. In this first example, we're asked to make an enlargement of the shape below using a scale factor of 3. So we're looking to make an enlargement. The scale factor is 3, which basically means I'm going to take all of the sides there and I'm going to multiply them by 3. So the first thing to do is establish how long are the sides currently. So all we've got to do is count the boxes here. So 1, 2, 3, 4, 5 here. That's 1, 1, 1, 1, 1, 1 and 3. And then we're going to take those numbers and we're going to multiply them all by our scale factor. So the only numbers I have here are 1, 3 and 5. So 1 times 3, 3 times 3 and 5 times 3. So taking the 3 numbers that are shown up here and multiplying them all by 3. So 1 times 3 is 3, 3 3s are 9 and 5 3s are 15. So when I come to draw this, I can use this as a little reference point. So this side here that's 5 boxes long, 5 multiplied by 3 is 15, so I need to draw that 15 boxes long. Now you would use a ruler for this. On this software I don't have a ruler option, so I'm just going to do it freehand best I can. We'll then look at the sides that are joined to this one. So this goes down 1 and this goes down 1. 1 multiplied by 3 is 3, so instead of going down 1 and 1, it's going to go down 3 and 3. So quickly sketch them in. And then again, go back to this shape here. This is 3 along from this point. Now 3 multiplied by the scale factor of 3 gives me 9, so instead of going 3 along here, I'm going to go 9 along here, so I'm going to sketch that in now. And then lastly, just looking at these are 1, 1 and 1 and another 1. Now, when we multiply the 1 by 3, we get 3, so it's going to be 3 down, 3 along, 3 up and 3 across. So we can just count through them and make sure we get all them right. So 3 down, 3 across, 3 up and 3 along. So this shape we've drawn here, all of the lengths are 3 times as long. In this question here, we're going to make a reduction of the shape and we're going to use a scale factor of a half to do that. Now what happens when you multiply something by a half is basically you just find half of it. So half times 4 would just be half of 4, which would be 2, and so on. So first thing I'm going to do again is we're going to write down the length of the sides that we can see. So that's 4 boxes, 4 boxes, 2 boxes and 2 boxes. Now what you'll notice here is I've kind of left this diagonal part. Now they can sometimes be tricky, so what I would always do is try and work out our horizontal and vertical lines first, and then what you'll often find is this bit can just be filled in quite easily afterwards because it has to join these two sides together. So let's start off with our 4 here. So we've got 4 and we've got 2, and they're the only 2 lengths that I can see on this. So we're going to do 4 and 2 are my 2 lengths, and we're going to take both them and we're going to multiply them by this scale factor of a half, so times a half and times a half. Now, what I said at the start was if you multiply something by a half, it's the same as finding half of that thing. So 4 times a half is just half of 4. Half of 4 is 2. And then the same 2 times a half is just half of 2, which is 1. So when I come to redraw this shape, all I've got to do is now have a look at this. This side here is 4. 4, when I multiply by the scale factor, becomes 2. So this length of 4 will change now and become a length of 2. This 4 along here, again, will change and become a length of 2. This 2 going up the way, 2, remember, when I multiply it by half becomes 1, so I'm going to go up just 1. And then at the top here, a long 1 as well. And what you'll find, once I've done all the horizontal and vertical lines, then this diagonal becomes easy, because there's really only one place it can go, so I can just fill that in there. And that then is a shape where all of the lengths of the sides here are half the length they were before. So we've reduced it by a scale factor of a half. Now, make sure I've not used a ruler, because as I said, this software doesn't really allow me to use a ruler, but you should use a ruler for when you're doing questions like this. Now, this question here is slightly harder than the ones before, but it follows the same ideas. And the thing that makes it a little bit harder is this kind of diagonal, these 2 diagonals here. So we're going to look at a way to kind of address that if it comes up. What I said before was try and, first of all, label the lengths of the sides you know. So 1, 1, 1, 1, 1, and 2, and another 1. These 2 here we don't really know the lengths of because they're not horizontal or vertical, so I can't just count boxes. So what I'm going to do is I'm going to come to them at the end. I'm going to take my 1 and my 2 here, okay, and I'm going to multiply them by my scale factor of 2. So 1 times 2 is 2, 2 times 2 is 4, and I'm going to start to draw that, but I'm going to avoid these two lines for the moment, and we'll come to them later. So 1 up becomes 2 up, 1 along becomes 2 along, and so on. So we're going to just double all of the length. So 2 up, 2 along, 2 up, 2 along, 2 down, and then we're on this one. So this is 2 here. We're going to double that. 2 times 2 is 4, so we're going to go 4 along, and then we're going to go 2 down. Now there's lots of different ways you can approach this, but what I would tend to do is I'd tend to stick to the horizontal and vertical idea. So I would say, well, to get from this point here, if you can see it up here, to get from this point here to this point here, I need to follow the horizontal and vertical lines. I need to go 1 box along and 1 box down. Now 1 box along and 1 box down in the enlargement will become 2 boxes along and 2 boxes down. So I'm just going to count that out. 2 boxes along and 2 boxes down, and then go back and put a dot in there. And then what I can do is I can quite easily join these up, and I've got them in the right position. So try and work in horizontal and vertical distances only. It'll make it a lot easier. Last example here, again, similar. We're going to make a reduction of this shape. We're going to use a scale factor. And again, I'm just going to look at the horizontal and vertical lines here. This is 3 and this is 6, so I'm going to quickly write them on, 3 and 6. And then I'm going to use the scale factor of a third here. So 3 times a third and 6 times 1/3. As we did with the half earlier on in the other example, remember 3 times a third is just the same as a third of 3. Okay, so a third of 3 is 1, and then again 6 times a third, that's just the same as asking what's a third of 6, so 6 divided by 3, and that is just going to be 2. So when I come to draw my reduction here, all I've got to do is the 3 down here, when I multiply it by a third, that becomes 1 down, and the 6 along, when I multiply that by a third, it becomes 2 along. So I'm going to go 1 down and 2 along instead. So 1 down and 2 along, and then the diagonal part again is going to take care of itself because there's literally only one place that can go. So we just sketch that in, and that shape there is a reduction of this shape where all of the sides are 1/3 of the length.